Alright, hello, my name is Addison Ferry, and today I will be covering the Wittig reaction. Alright, so as you can see here, this is the Wittig reaction, and the two reactants of the Wittig reaction are this carbon compound with oxygen attached to it, and the Wittig reagent, which I'll explain later, and it forms two new carbon-carbon bonds, which is shown here by the alkene, and phosphorus byproduct, which is known as triphenylphosphine oxide. Now, the Wittig reagent is known as an organophosphorus reagent, and I will go over that later on in the presentation. Okay, so an important part of the Wittig reaction is knowing what it does. So it ends up forming two new carbon-carbon bonds, one new pi bond and another new pi bond. So the products of this reaction are obviously two carbon-carbon bonds, and there's a phosphorus byproduct, which is pronounced as triphenylphosphine oxide. Okay, so an important part of Wittig reactions are being able to see examples. Now, the first example I have is a cyclohexane with oxygen bonded to it, and the triphenylphosphine oxide attached CH3, and as you can see, the oxygen gets replaced by the CH3, and then there's the phosphorus byproduct with the oxygen attached to there. For the second example, there's the Wittig reagent here,
right,
and basically the same thing happens. The oxygen gets replaced by the CH2, and the oxygen then binds to the triphenylphosphine oxide here. Alright, so the Wittig reagent is an organophosphorus reagent which contains a carbon-phosphorus bond. Now, a typical Wittig reagent has a phosphorus atom bonded to three phenyl groups, which are shown here. And in addition to the three phenyl groups, there's another alkyl group that bears a negative charge, which is shown here. Now, an abbreviated Wittig reagent is known as alide, and it's important that you include the positive and negative charges on the compound.
Is that cool?
Alright, so alide is a species that contains two oppositely charged atoms that are bonded to each other, and both of these atoms have octets, which is shown here. Alright, so here we're going to look at the resonance structures of the Wittig reagent. And according to our book, the Wittig reagent has no net charge, no matter which resonance structures is drawn. Now, since phosphorus is a third row element, it can be surrounded by more than 8 electrons, or more than octet. So a second resonance structure can be drawn here using a double bond instead of a single bond between the phosphorus and carbon.